What's going on, everybody? It's Mr. Diamond, and we're going to be working out the two examples from the notes involving the wave equation. Now, the wave equation is something that you will want to have memorized. It's pretty short, but you don't need to have memorized the value of c. So the equation is c equals lambda v, or c equals upside down y v. And c is the speed of light, which is 3.00 times 10 to the 8th meters per second. Lambda y is equal to wavelength, and then v is equal to frequency. So in this problem here, determine the frequency of an electromagnetic wave that has a wavelength of 0.0534 meters. We can rearrange c equals lambda v, and that will give us v equals c over lambda. So we'll have 3.00 times 10 to the 8th, and that'll be meters per second, over our wavelength, which is 0.0534 meters. Now notice on the units for this that our meters will cancel and we'll be left with the seconds. So frequency's units is actually going to be in 1 over seconds, or inverse seconds, which can be written as s to the negative 1. So that's kind of one of the weird parts about this, is your units are going to be a little bit wonky on this. You're not going to actually end up as seconds. It's going to be inverse seconds, or just per seconds. Now we're going to take this number and we're going to go ahead and plug it into our calculator. I'm going to put this in parentheses, 3.00 times 10 to the 8th divided by 0.0534. And I got a really big number in this case. So what I'm going to do is I am going to go to my, let's see where it's at, mode, and we're going to do psi, and I'm going to hit enter. I'm going to quit out of that, and I'm going to hit enter again, and this time it's actually going to give me the frequency, the number that I want for this, as a scientific notation number. So we're going to go ahead and plug that in, and this time I've got 5.62 times 10 to the 9th. This e right here is times 10 to the 9th. Okay, so other than that, we also have our second equation, and again, this is going to be inverse seconds. We have a second equation. The least energetic electron of hydrogen gives off red light with a wavelength of a very small number. This is 0.8 zeros. There's 8 zeros here. 656 meters. What frequency will it have? Well, we're going to plug it into the same equation. V equals c over lambda. We'll do 3.00 times 10 to the 8th over, and then we'll have 0.12345678656. Now you're going to end up with an even smaller number. My calculator is still in scientific notation form, which will be good because this number you're definitely going to want in scientific notation. So we've got 3.00 times 10 to the 8th divided by 0.12345678656. This time I got 4.57 times 10 to the 16th power inverse seconds. So it's a pretty straightforward calculation, but there will definitely be one like this on the test. Make sure that you feel pretty comfortable doing this. Again, you want to know this equation, that c equals lambda v, but I will tell you that c is equal to 3.00 times 10 to the 8th meters per second. I might not tell you what c is. This would be actually a good multiple choice question of what does c represent, and you would want to know that c is equal to the speed of light. Anyway, I hope that makes sense. If you have any questions, please feel free to leave them in the. You can either send me an email, you can attach them to this video, or you can ask them in class. Otherwise, this is Mr. Diamond. I hope you have a great rest of your day.